Hello all. So the video's topic is cipher modes. There are four cipher modes or five cipher modes we have to know about in this video. So the first mode is electronic code book or ECB. It is known also as ECB. So it is the simplest mode of the operation. Simplest of all modes, and the incoming plain text or TT, the whole PT, suppose the whole rectangle, we are dividing it in 64 bits block. So the size of each block should be 64 bits. It is a type of block cipher where the plain text data is processed in terms of block. So for all blocks in message, same key is used for decryption and encryption. So let us draw a picture how the encryption and decryption works. So let me first show the encryption, and it will be the decryption. So here the key comes and the plain text block is coming here. I am writing it as TT1, which is plain text block 1. Here it is encrypting and it is giving output as cipher text 1 first block, and continuously like this, like here should be key and here should be TT2, and here it is also encrypting, and the output is ciphertext2 or CT2. So it is like this. And how the decryption is executed here? So decryption is rather simple. We will do the same process, but the position of the ciphertext block and the plaintext block will be reversed. So CT1 will come here first. We will use the same key which we have used in the encryption to decrypt, and we will get the output as plaintext 1. So it is same for all other blocks. So it is rather simple, but the disadvantage is, so what is the disadvantage? Can you guess? The disadvantage is we are using same key in all the blocks. So if block 1 is equals to block 3, then the ciphertext block 1 and ciphertext block 3 will always be same because we are using the same key here. So in the encrypted message, like encrypted message, the this block and this block is same. So it will give some hint to hackers or analysts about the repetition of the text. It should not be here, which is not intended actually. So to circumvent this problem, we come to the next mode, which is cipher block chaining or CBC. So the second mode of the cipher is cipher blockchaining or CBC. We have seen the disadvantage of um, the previous one, or the electronic code book ECB. The same key is used, and if the blocks are same, the ciphertext output will be same. So it will give some hint to the hackers. So in the cipher blockchaining, we have to use it like this, like chaining. What is chaining? We have to know about first the chaining. So what is chaining? It is a feedback mechanism. So what is feedback mechanism? It is also access block cipher, first of all. So the feedback mechanism means it is in the block cipher, in cipher blockchaining, the result of encryption, like the encryption of block 1, we will give output as ciphertext 1. Okay. So the ciphertext 1 will be used in the encryption of the next block, which is CT2. So in this way, it is working as the feedback. So how we can write the diagram? So here it is a concept of IV. IV is initialization vector. Initialization vector has random values, and we can also make it public, randomly generated, and we can also share it in public. So how we can use the IV in the cipher blockchaining? So first IV is here. IV's value will be stored with plaintext 1 or PT1. I am writing this in short. After that, encryption will be done using the key, and we will get the ciphertext 1 or CT1. So after that, now the feedback will come. The CT1 will be stored here with plaintext 2. Encryption will be done using key, and it will output ciphertext 2, and consequently like this and so on. So the decryption process, how will be done? It is the encryption, and this is the feedback. This whole part is feedback. So how we can do the decryption? Decryption is done is actually the opposite. So the ciphertext block 1 is here. We are decrypting using the key. After that, we have to use IV value to XOR. After that, we will receive the plaintext 1 or PT1. because we have used ciphertext 1 as a feedback to make the plaintext 2 using the XOR. So we will be using the ciphertext 1's value as a feedback here also. So here will come ciphertext 2. After that, we will decrypt using the same key. After that, XOR will be done and we will receive plaintext 2. So it is actually the opposite. IV is important for the first block. And why we can use XOR in the reverse? Because XOR has actually a reverse property. Suppose 110 is here and we are doing XOR with it. So the output will be 0 and 100. So if we use again like the output here and here it is 010 again, so we will be receive the actual message or 110. The actual message was this and we have also returned here as 110. So it is the reversal property. So the disadvantage, disadvantage is it is slower from ECB because we have to encrypt and we have to use the random initialization vector value. Then we have to use the feedback because in the ECB the all vectors or sorry the all blocks encryption and decryption was independent from each other, but here the encryption and decryption both are dependent on the previous blocks. So it is slower from ECB as encryption decryption depends on previous blocks. Sorry, not blocks, it is only block because only the previous block is used for encryption and decryption. Secondly, if this is the first disadvantage, the second disadvantage, if ciphertext is changed by attacker even for a one bit, the consecutive encryption and decryption will become impossible. So how? So in the city 1, if we have changed one bit and then it is going as feedback to the next plain text block to XOR it, and after that it will be encrypted. So the ciphertext 2 will be changed from its actual intended value. And same for the decryption. If ciphertext value is changed, after that it will be XORed. So the first of all the plain text block will be actually altered. So it will not give the proper decrypted message. So the next mode is cipher feedback mode or CFB. CFB is actually works on block cipher but acts as string cipher. Now you will ask how and why I am saying this like that. So we will see the work of these modes, we can understand easily. So in the cipher feedback mode, CFB is important or useful. Useful when any application or service is character oriented and every character is important. So here data is encrypted in units that are smaller. In some system it is 8 bits. So now how CFB works. So what is J? J is important. J is number of bits we are dealing at a time. This is important. So in the step 1, here it is a 64-bit IV initialization vector. What is IV? I have mentioned here. Why it is here? Initialization vector. But IV is kept in a script register. It is very much important. So first IV will be encrypted using the key and we will get encrypted IV. After that in step 2, first J bit, because J is important, that's why I'm highlighting. First J bits of encrypted IV is solved with first J bit of plain text and the result will be ciphertext C. Sorry, I have not um, highlighted the J here because J is very much important in this mode. So in the step 3 or the next step, the initialization vector will be left shifted. So IV was like this. After that, IV is left shifted. Left shifted by J bits. Now this position is actually empty. Remember, I have mentioned here left shift. Okay, not circular left shift. Not circular left shift. It is only left shift. If the circular left shift was done, like the first initialization vector is 1, 2, 3, 4, and J is 2, so it will become 3, 4, and then 2, 1. Sorry, it will not be 2, 1. It will become 1, 2. So, like this. Like first 1 will go, and after that 2 will go. So 3 will come at the very left, and 2 will be come at the very right. But in the left shift, same 1, 2, 3, 4 only, and J is 2. So 3, 4 will be there, and this part is empty. This is actually needed in this part. So now you will question how we can fill this part. Yeah, to fill this part, we will take the cipher text C, and we will be using this leftmost J bits to fill here. Yes. So now, if here it is 1, 2, J will be filled as 1, 2. So how it is the whole diagram? Encryption. So first IV, here it is shift register. We are using key to encrypt it. After that, take just the leftmost J bits. Now it will be solved, and plain text will come here, which will output cipher text of J bits. and here it will be plain text of j bits, and here it will also become ciphertext of j bits. So necessarily the full ciphertext will be shifted in the IV because the whole ciphertext block is j bits long. So there must be confusion like what part of j bits should be shifted here, like the um, in the left part or the right part. It will happen in the exam time because I am now writing here. I have remembered it, but in the heat of examination, you can be confused. So the ciphertext j bits is now sent to IV here again shift register. Like this part, the ciphertext would be the circular left. Sorry, the left shift only. So here it will be encrypted again using key, and just the leftmost j bits. It will be XORed again with the plain text, and it will output ciphertext of next j bits. So it is how will be decryption will be done here. Encryption will be done using the same key. Take just the leftmost j bits, but the decryption process will be just simply reversed. So only these parts it will be reversed. Like we are giving ciphertext as j bits, and we will be receiving plain text as j bits. And here also we are giving ciphertext as j bits, and we will be receiving plain text of j bits. So this is the decryption part. So for better understanding, I am marking these positions here. Now we are at the fourth mode, or output feedback mode. Almost same as Cipher feedback mode, or CFB. The same mode we have used in the previous step. So what is the main difference? So this is the encryption part. I will be just changing in this diagram. Um, Leftmost J bits. Instead of using the cipher text block of the previous step, we will be using the IV's J bits, and we will be using it to change the IV used for the next plain text block. This is the encryption part. How will be the decryption part? Decryption part is actually same as before. The output will be reversed. Like we will be receiving the plain text, but we have to input the ciphertext of J bits, and it is also the same. So what is the main drawback here? Drawback is if both the ciphertext and checksum of the message is changed, the hacking is undetectable. So next is the counter mode, or it is the sub part of OFB. It uses sequence numbers, which is known as counters, as the input of the algo. Now how it is done? So first we are using counter. We are using the key in clip. After that it is sorry. After that it is solved using the plain text or PT1, and we will get output as CT1 or ciphertext 1. Next it will be counter plus 1. After that it will be encrypted using the same key, and then it will be solved using plaintext 1, and the result is ciphertext 2. Sorry, it is plaintext 2. Like sequentially it will go on, and counter will be go on like counter plus n and so on. This is the encryption. So how is the decryption? It is actually same. Just these two parts will be reversed. Like here we will be giving ciphertext 1. Here it will be outputting ciphertext plain text 1, and here we will be giving ciphertext 2, and the output will be plain text 1. So these are all the modes. So in the recap, we have discussed about 5 modes. So what are the 5 modes? First is electronic codebook, cipher block chaining. Then is cipher feedback. 4 is output feedback. 5 is counter. Basically these two acts as block. 3 and 4 acts as stream cipher, and 5 is just a variation of the output feedback. So these are all the steps. I will be linking this whole document in the comment section. Thanks for watching.